Okay, this is an unsimplified fraction because you cannot have a radical in the denominator of a fraction. So we're going to rationalize this by multiplying by root 2 on the top and bottom. And this is going to give us a root 14 on the top, and the square root of 2 times the square root of 2 is just 2. And that's called rationalizing the denominator. That's a simplified fraction. Okay, there's a couple ways to rationalize this. One way, which I think is a mistake, is to try to multiply top and bottom by 50. You'll get there, but you're going to have a whole bunch of simplifying to do that is going to be difficult to do. So instead, think of the smallest number that's a perfect square that 50 is a factor of, and the answer is 100. So I'm going to multiply the top just by root 2, the top and bottom. This will give us a negative square root of 100 on the bottom, which is 10. In the numerator, we have root 7 times root 2, which is root 14. And that cannot be simplified, so that's your final answer. Okay, there's a couple things going on here. First of all, 24 can be simplified. I'm going to write that as a square root of 4 times 6. And then we have the square root of x on the bottom. I'm going to take out the 4 by square rooting it, and we'll get a 2. And I'm also at the same time going to multiply this bottom by x, like this. And that's going to give me root x times root x on the bottom will give me x like that. That rationalizes the bottom. And then we take out this 2, and we have a 2 times the square root of the 6 that's left behind and the x that we popped in there. So this is going to be root 6x. And nothing can simplify. You can't cancel this and this because this is inside the radical, that's out. So those cannot cancel. So this is your final answer. Okay, again, a couple things going on. 49 is not a perfect square, but, 98 is not a perfect square, but 49 is. So I'm going to factor this as negative, I'll make this 49 times 2, and 3 is not divisible by 2, so I'm going to rewrite this as r squared times r. That's my r cubed. On the bottom, I have s. And what I'm going to do is I'm going to multiply this by s, so I got to do the same thing to the top. That gives me the square root of s squared on the bottom, which is s. And then I'll take this 49 out. I almost forgot my negative here. Okay. I'll take this 49 out, and that's going to become a 7. I'll take the r squared out, and that'll become an r. So I have a 7r on the outside times the square root of the stuff that I couldn't take out, which is 2r and s. So that's the final answer. Okay, a couple of things going on. 288 is not a perfect square, but 144 is. You may not see that, so you might have to sit there and factor this out. But I can see that 144 is there, so I'm going to rewrite this as the square root of 144 times 2 to start there. 7 is not divisible by 2, so I'm going to rewrite this as x to the 6 times x over y to the 9. Now, in order to bring this out, I'm most concerned about the denominator. This is not divisible by 2, so I'm going to have to multiply by y, so I get y to the 10 on the bottom. But if you do that to the bottom, you do that to the top as well. Now, you take 144 out by square rooting it and get 12. You take this out and you get x cubed, and nothing else in the numerator can come out. So in the numerator, you have a 12x cubed, and you're left with the square root of the things you couldn't take out, which are 2x and y. And in the denominator, you have y to the 10. When you take that out, you divide the 10 by the 2 here, and you get y to the 5. And that's your final answer. Okay, in order to take something out of a cube root, we need something cubed. And so instead of multiplying this by 3 in the denominator, I'm going to multiply by 3 squared. That's going to give me 3 to the third on the bottom, and when I take that out of a cube root, I'm going to get 3. But if you multiply by 3 cubed on the bottom, you have to multiply that on top as well. And so in the numerator, we have a 2 and a 9, and those will multiply to be 18. So in the numerator, it's still in the cube root because it couldn't come out, but we have 2 times 9, which is 18. And then now that's your final answer. By the way, you cannot cancel this and this because this is inside the radical and that's out, so they can't cancel. Okay, one way to do this would be to multiply by 9 squared. An easier way to do it would be to factor this. Don't worry about factoring the numerator, but factor this, and I'm going to have the cube root of 3 squared. And now I can see I only have to multiply by 3 in order to get 3 cubed, which I can take out. So if I had the 4 in the numerator, I'm going to multiply by 3 down here, so I do that in the numerator as well, and I'm going to get the cube root of 4 times 3 is 12, and here I have the cube root of 3 cubed, which is just 3, and that's it. Okay, this is not simplified because we have a radical in the denominator. And we can't bring this out the way it is because 2 is less than 3. So we're going to multiply the top and bottom inside of the radical by r. And that'll give us r cubed in the denominator, which will come out as r. So we have a negative in front of the fraction, and then in the numerator we have the cube root of 2pr. Make sure that it covers everything up there. And that's it. Okay, so for the numerator, we have 16, and we'll factor that. 16 is 4 times 4, this is 2 times 2, this is 2 times 2. So this is the 4th root of 2 to the 4th power, which in the numerator is just going to be 2. In the denominator, we have x to the 1, so we're going to need to multiply by x cubed inside of the radical in order to make this in x to the 4, which will just come out as x. So now in the numerator we multiply by x cubed. So we have the 4th root of x cubed in the numerator, and we have just, this came out as just x. So we have x in the denominator. And this can't come out because 3 is less than 4. But the 2 did come out. So that's our final answer. Okay, here we have z to the 1, but we need it to be to the 4 in order to bring it out. So in the denominator, I'm going to multiply by z cubed. So I have to do that in the numerator as well. So in the denominator now I have z to the 4th, which just comes out as z. In the numerator, I can't bring any of this stuff out, so we just end up with the 4th root of 2yz to the 3rd power. Okay, in the denominator we have a radical, so this is unsimplified, but it's a binomial. The only way to get rid of a radical in a denominator that's a binomial is to multiply by the conjugate pair. So if we do that to the bottom, we have to do that to the top as well. When you multiply by a conjugate pair, you always have the square of the first item minus the square of the second item. So that's going to be 3. In the numerator, we just distribute this 2, and we're going to get 8 minus 2 root 3. So this becomes 8 minus 2 root 3 over 13, and that can't be simplified, so that's our answer. Notice we've rationalized the denominator. There's no radical down there. Okay, we have radicals in the denominator, but it's a binomial. Again, the only way to get rid of that is to multiply by the conjugate pair. So we have to do that to the numerator as well. So in the numerator, I'm going to distribute this, and I'll get 6 root 5 minus 6 root 3. In the denominator, when you multiply by a conjugate pair, you get the square of the first item minus the square of the second item. So this is going to be 6 root 5 minus 6 root 3 all over 5 minus 3 is 2. This is not a simplified fraction because I have 3 terms, 2 in the top and 1 in the bottom. but they're all divisible by 2. So you have to divide the 2 out in order to simplify. So now it's over 1, so the denominator is going to disappear because we don't write fractions over 1. So our final answer is going to be 3 root 5 minus 3 root 3. Okay, we have a binomial in the denominator with radicals, so I'm going to multiply by the conjugate pair and to get rid of it. So I do that in the numerator as well. So in the numerator, I'll distribute the -4 and get -4 root 3 minus 4 root 7. In the denominator, we get the square of the first item, which is 3, minus the square of the second item, which is 7. So we have -4 root 3 minus 4 root 7 over -4. Now, every one of these terms is divisible by -4, so I'm going to divide out the -4 and get a positive 1 here, a positive 1 there, and a positive 1 there. So we're going to get, we don't write 1 root 3, we just write root 3 plus root 7, and we don't write over 1. Okay, here we have radicals, but there's a binomial, so I have to multiply by the conjugate pair to get rid of it. Now, whenever your conjugate pairs are 1 apart with radicals in it, you're going to end up with 1. You'll see why in a second. But let's do it like this. Now, in the denominator, I'm going to have to FOIL because I have a binomial times a binomial. My first is 1 times root 7, which is root 7. My outer is 1 times -root 6, which is a -root 6. My inner is -root 2 times root 7, which is a -root 14. And my last is -root 2 times this, which is a positive root 12, which is going to be able to simplify because that's 3 times 4 in there. In the denominator, when you multiply conjugate pairs, it's the square of this, which is 7, minus the square of this, which is 6, and that's going to be a 1, so the denominator is going to disappear. Now, I need to rewrite this, root 12, as root 3 times 4, and then I take out the 4 and it becomes a 2, so that last term becomes a 2 root 3. But everything else didn't change, so I have a minus root 14 here, a minus root 6 here, and a root 7 here. None of these are like terms and nothing can be combined, so that's the final answer. Okay, we have binomial in the bottom, and notice that these radicals are 1 apart. I'm going to end up with 1 in the denominator, which is going to disappear, but let's show it. I have root 6 plus root 5 and root 6 plus root 5 in the numerator. Because I have a binomial times a binomial, I'm going to need to FOIL. In the numerator, my first is root 2 times root 6, which is root 12, which is going to be simplified in a minute. My outer is root 2 times root 5, which is a positive root 10. My inner is negative root 3 times root 6, which is a negative root 18, which is also going to be simplified. And my last is negative root 3 times positive root 5, which is a negative root 15. In the denominator, the square, when you multiply conjugate pairs, it's the first item squared, which is 6, minus the second item squared, which is 5. That's going to turn into a 1 in the denominator and disappear. Now I'm going to rewrite this as the square root of 3 times 4, and when we take out the 4, it becomes a 2. So this becomes 2 root 3. This cannot be simplified. This is the square root of 9 times 2. And when you bring out the 9 by square rooting it, you get a 3. So this term becomes a negative 3 root 2. And this cannot be simplified. So we have 15 like that. None of these are like terms, and none of them can be combined. So that's the final answer. And it was all over 1, so we just got rid of the denominator. Okay, we have a binomial in the denominator with radicals. To get rid of it, we have to multiply by the conjugate pair, which is root x plus 2 root y. we do that to the numerator as well. So in the numerator, I'll distribute that and get 4 root x plus 8 root y. In the denominator, when you multiply conjugate pairs, it's always the square of the first, which is x, minus the square of the second. Now to square this, we square this to get 4, and we square this to get y. So this squared is 4y. This is a simplified fraction because we have 4 terms, and each of the 4 terms is not divisible. If there's like an even number here, then we would have to cancel that all out. But there's a 1 here, so we can't cancel anything out. So this is our final answer.